Alright, Assalamualaikum and good afternoon. So today we will proceed our lecture on new topics. This is a new topic and last topic. Okay, last topic for strength of material one course. Okay, for this course, this is the last chapter, last chapter. So which is analysis and design of beam. Alright. So in this chapter, we are going to apply the concept that we already learned in the previous chapter, especially for the concept in shear stress and also normal stress. Okay, normal stress due to bending. Okay, so we will apply that concept in this chapter. All right. So table of content, this is the presentation outline. We are going so this is the things that the subchapter that we are going to learn today. The first, I will start with the introduction, okay, and then I will proceed with the definition of the beam, because we are going to analyze the beam. So it is good to really understand what is the definition of the beam. Okay, so because some student get confused between beam and column. Okay, beam and column. So I will explain later what is the difference. And then next, I will talk about internal shearing force and also bending moment of the beam sign convention. Okay, so positive, minus and positive. So how when we do sectioning, so which direction should be the shear force and also bending moment. So that's what we call as a sign convention. And then in this chapter, we are going to draw the shear force and bending moment diagram. Okay, so remember in this chapter, what we want to do is to draw the shear force and also bending moment diagram. So there are two methods. Okay, there are two methods to draw that diagram. The first method is method of section. Okay, so I will explain what is the method of section and then do some example step-by-step analysis how to construct or how to draw the shear force and also bending moment diagram. And then the beam can be subjected to different load. Okay, there are two types of load basically subjected to the beam. The first one is the concentrated load, and then the second type of load is distributed load. Okay, so distributed load have different type, which is one is rectangular distributed load, the second one is the triangle distributed load, and the last one is trapezium type distributed load. Okay, so what's that? I will explain later. Okay, and then we will do some example. I will show how to draw the shear force and also bending moment diagram. And then the second method is graphical methods. But in your course, strength of material 1, we will not cover the graphical methods. Okay, so we only the scope for strength of material 1 is only method of section. Okay, so but if you are interested on graphical method, so you can go through my slide, because I already put the notes for graphical methods. Okay, but we are not going to I'm not going to explain what is the graphical methods. Okay, basically the same, but the graphical method is more easier. But the problem is if you are not really understand the concept, okay, the fundamental of the relationship between shear stress and also bending moment, so it's quite difficult to apply the graphical methods. But if you really understand few concepts, then graphical method will be the easiest method to construct the shear force and also bending moment diagram. Alright, so this is the lesson outcome. So basically at the end of this chapter, we expect student to be able to explain the meaning of shear and bending moment diagram. Okay, so I hope after we finish this lecture, so you should be able to explain what's the shear force and also bending moment diagram. And then we also expect the student is able to calculate and construct, okay, or draw the shear and bending moment diagram. Okay, first you know what is the meaning of shear and bending moment diagram, and then the second one you should be able to construct or to draw the shear and also bending moment diagram. And then also we expect the student is able to explain the relationship between load, okay, shear stress, and also loads mean external load, and then internal shear and also internal bending moment. Okay, so the point number 4, last point, is calculate and construct shear force and bending moment diagram by using integration or graphical method. Will not be covered. Okay, I already explained. We will not cover for the last point, okay, of the lesson outcome. Alright, first, for the introduction, in this chapter you should know how to draw the shear and also bending moment diagram. Okay, so that is our main. This is the main purpose, okay, for this chapter. So we expect the student know how to draw shear and also bending moment diagram. Okay, so before you can understand, before you learn how to draw shear force and also bending moment diagram, first, what is the shear diagram? Okay, what is the shear diagram and what is the bending moment diagram? Okay, so by definition, shear diagram is the internal shear force F versus X, which is arbitrary position along the beam. Okay, so alright, so let me explain here. Alright, for example, if you have a beam, okay, for example, you have a beam, okay, and then supported at both ends. For example, you have pin support, and also the other end is the roller support, and then the beam is subjected to load P, for example. Then what happened to beam is the beam will deform. Okay, the beam will deform. Alright. So if you know the concept of shear stress, what is the shear stress? Sorry, what is the shear force? Okay, if you remember shear force, if you have member and then there are force that apply parallel to the cross section of the member. So this is the cross section of the member A, and then this force, we apply the force F, for example F, which is parallel, okay, which is parallel to the cross section area. So this is what we call as a shear force, okay, F, or I use the symbol V. Okay, so this force we call it as a shear force because why? Because the direction of the force is parallel to the cross section. Okay, so same thing to here. Okay, if you see here, this is the cross section of the beam. Okay, this is the cross section of the beam, and then this force is parallel. Okay, is parallel to the cross section of the beam. So if we analyze the cross section of the beam, if we do the sectioning and then we analyze the cross section, okay, we draw this part. Okay, let's we do sectioning here. Okay, so what happened? Okay, so here I do sectioning here. So this is the beam. Okay, so I take the left part of the beam. Okay, left part of the beam. So what happened is, because we have P here, so it will develop the shear force will be developed, which is V. Okay, the shear force will be developed, which is V. Okay, because this concept is same with this concept. If they are force which is parallel to the cross section, and then what happen, this is what we call as shear force, and if we do the sectioning, we will have the internal shear force. Okay, same thing to here. Okay, for the case of beam. And then if you see here, when we apply the load P, the beam will deform or bend. Okay, bend. Okay, the beam will bend. So what is the force that cause the beam to bend? Okay, of course we have the bending moment. Okay, so we should have the bending moment. So this force basically cause the material to bend. Okay, so for the case of beam, okay, so if the load applied on the beam is, if there is a load applied on the beam, so what happened, the beam will the internal force, okay, internal shear force and also internal bending moment will be developed in the beam. Okay, so for the case of beam, again I repeat, for the case of beam, okay, when the beam is subjected to load P, okay, for example, so the internal shear force and also internal bending moment will be developed in the beam. Okay, all right. Okay, so that is the first concept you should understand. Okay, so let me delete this one first. Okay, now I proceed. What is the shear force diagram? Okay, what is the shear force diagram? Okay, what is the shear force diagram? Is the V versus X. Okay, so V is the internal shear force. So X is the arbitrary position along the beam. Okay, for example, I give you an example. You have a beam, okay, and then subjected to load P, okay, and then this is the shear force diagram. Shear force diagram is the V versus X. Okay, V versus X. So what is the X? X is measured from reference line. Let's say this is the reference line. So F is measured from the reference line to any point in the beam. Okay, to any point. Arbitrary position means any point of the beam. Okay, so that is the X. So what we are going to do is to determine what is the internal shear at each point. Okay, at each point in the beam. Okay, for example, this point I represent by x1, this point I represent by x2, this point represent by x3. Okay, so we are going to determine what is the shear force at x1. Okay, at x1. For example, let's say here is the x1, here will be the x2, and here will be the x3. Okay, so for example, the internal shear force at x1 equal to 10, for example. So we draw, so x1, V equal to 10. And then what is the shear force at x2? Let's say at x2, the value of V is 20. So we draw 20. Okay, let's say at point 3, V equal to 15, for example. So somewhere here. And then we draw the graph. Okay, up to here. Okay, so this is the point where x equal to L. Where the beam, the L is the overall length of the beam. Okay, so this is the shear force diagram. Okay, shear force diagram. So V versus X. Okay, so from here we know, from this graph, we actually can determine what is the maximum shear stress. Okay, sorry, what is the maximum shear force? Okay, shear force, also maximum shear stress. Okay, so maximum shear force means maximum shear stress. So from this diagram, we can identify which which point give highest internal force. Okay, so that will be the critical point. Okay, so that is the shear force diagram. Okay, now bending moment diagram. Okay, bending moment diagram. So what is the bending moment diagram? So same thing to previous slide. If we have a beam, for example, beam, and then we are going to draw. Okay, bending moment diagram means the bending moment. Okay, bending moment, internal bending moment versus x. Okay, versus arbitrary position, which is x. Okay, x means any point at the in the beam. Okay, so for example x1. Okay, so that will be the x1, and let's say this is x2, that will be the x2, and then let's say the value for the value of m at x1 equal to 10, for example, and then the value of x2. Okay, the value of m at x2 equal to 10, for example, same. Okay, and then we can draw the value of and then we can draw the distribution of bending moment. Okay, bending moment value. So from this diagram, we can identify where is the maximum of internal bending moment. Okay, for this case, this point lah. This is just example. So and then we can identify. Here will be the critical point. Okay, because the m is highest. Okay, the m is highest, so that will be the critical point. So we are only interested to calculate the stress. Normally we are only interested to calculate the stress at the point where the m is maximum. Okay, why m maximum? Why we are interested on the point where m is maximum? Because when m is maximum, then the normal stress will be maximum. Okay, because the normal stress is equal to mc over I. Okay, so m max, so that's why we get sigma back up to max. So that is the shear force and also bending moment diagram. So in this chapter, we are going to draw shear force diagram and also bending moment diagram. Okay, so that is the objective for this chapter. Alright, so I just read this sentence. Based on the bending moment diagram, the location and magnitude of largest bending moment can be determined. Largest maximum bending moment basically is equal to the possible failure initiation point. Okay, that's why we need to know where is the location of the largest or maximum bending moment. Alright. So as I explained before, basically there are two methods in constructing the shear force. Okay, shear force diagram and bending moment diagram. Okay, so there are two methods to draw this diagram. Okay, there are two methods. Okay, the first one is method of section, and the second one is graphical method. Okay, so in our in this course, I will talk only method of section. Okay, graphical method, I leave it to you. Okay. Alright, now before we start analyzing or constructing the shear force and also bending moment diagram, first we have to understand what is the definition of beam. Okay, what is the definition of beam? So beam, what is a beam? Beam is a slender member, okay, or thin member. Okay, slender member, thin member, where the load are applied perpendicular to their longitudinal axis. Okay, so if you have, for example, slender member like this, and then there is the load applied on the slender member, and the load is 90 degrees with respect to the longitudinal axis. Okay, this is the longitudinal axis of the beam. What is the longitudinal axis? What is the longitudinal axis? Longitudinal axis means the longest axis along the beam. Okay, if you have a beam and then the axis along the beam, we call it as a longitudinal axis. So if you have a beam and then the beam is subjected to the load, for example load P, and then the P is 90 degree with respect to the longitudinal axis, this is what we call as a beam. Okay, this is what we call as a beam. But if you have the same slender member, so this is slender member, slender member. If you have a slender member positioned vertically, okay, vertically, so this will be the longitudinal axis, and then the load is applied parallel, okay, parallel to the longitudinal axis, okay, parallel to longitudinal axis. This is what we call as a column. Okay, column. Tiang lah, macam tiang. Okay, so kalau tiang tu kita panggil column. Okay, column means the same slender member. So you can see here, this is a slender member, the same slender member, but one is positioned horizontally, one is positioned vertically, and the load is applied 90 degree. The load is applied parallel to the longitudinal axis. So this one we call it as a column. This one we call it as a beam. The beam normally we subjected to bending moment, will be subjected to bending. Okay, means that it will bend. It will bend. For column, it will also bend. Okay, also bend. But the mode of failure here, we call it as a buckling. Okay, so this is what we call as a buckling. This is what we call as a bending. Okay, so the beam will bending, the column will buckling. Okay, what is buckling? Okay, you will learn in detail in strength of material 2. Okay, so in strength of material 2, we have the topics on buckling. Okay, how to analyze, how to calculate the stress and strain of the structure under buckling. Okay, so forget about buckling. Okay, so we focus on the bending. So that is the definition of beam. Okay, slender member where the load are applied perpendicular to their longitudinal axis. Okay, now this load. Okay, we know that the beam is the slender member that's subjected to load, and then there are two types of load. Okay, there are two types of load. One is the concentrated load. Okay, one is a concentrated load. What is concentrated load? This one. Okay, or sometimes we call it as a point load. Okay, point load or concentrated load. The other one is distributed load. Okay, distributed load, this one, for example. Okay, number 2. Number 1 is a concentrated load or point load. Number 2, okay, is distributed load. Okay, so the load subjected, okay, the load that we can apply on the beam can be in two types. One is a concentrated load, the other one is a distributed load. Alright. So in real application, okay, normally the beam is subjected to distributed load, not concentrated load. Okay, so this is only in some cases. Okay, most in real application, so mostly the beam will subjected to distributed load. Okay, and then distributed load also have different type. Okay, I will explain later lah. Triangle type, rectangular type, trapezium type, and so on. Okay, different type. Okay, now we understand what is the beam. Okay, so now we proceed. What is the type of beam? Okay, we have several type of beam. First one is a simply supported beam. Second one is a cantilever beam, and the third one is overhanging beam. Okay, so how to differentiate between these three beam? Okay, Alright, so this is the example of simply supported beam where you have a beam and then it's supported at both ends. Okay, so you see there is a support at both ends. Okay, one pin support and the other one is roller support. Okay, roller support. And then what is the overhanging beam? Overhanging beam means the beam and then you have some excessive part of the beam, okay, the overhanging macam this is what we call overhanging lah. Overhanging. Simply supported beam, the support is positioned at the end, at both end of the beam, and then overhanging beam, okay, the second support is located in between both end. Okay, you have end of the beam, so one of the support is in between. Okay. And then what cantilever beam? Cantilever beam means the beam that support at one end. Okay, support at one end. So that's what we call as a cantilever beam.